this mean voltage is nothing but the equivalent of the degree. So, at 0 degree volt we calibrated that the voltage is 3.47. So, for each degree there is a variation of 0.01 volt. So, using that formula we have calculated the degree. And you know the distance, you should use the tan theta formula. Tan theta is opposite side by adjacent side. The adjacent side, which is the base of the triangle, is fixed. And we know the degree from the voltage, so now we can calculate the distance. Okay, so here in the formula we can see degree is equal to 3.47 minus volt into 100. When doing the calibration at 0 degree, when the angle between L1 and L2 is when the base angle is 0 degree, our voltmeter reading was coming 3.46. Change in resistance which due to 0 to 1 k ohm is variable resistance which will be changing. So the fixed resistance 1 kilo ohm is there. We are taking voltage across that. So as this value is changing, this voltmeter reading will also change. And after calibration, when we are doing change in voltage per degree, it approximately comes to 0.01. So that means starting 3.46 minus any value which we are getting on voltmeter into 100 will give us our degree 0.0141. So that we need to convert to radian. Now 10x approximation we needed to use because we used at mega 8 and in that we don't have the maths library function. So we went for 10x approximation, but it wasn't working that much for higher values. So afterwards we had to feed all the 90 values of 10 for every degree into the program, and then distance we can measure. And in our setup the base value we have selected as 81. Okay, now what is the advantage of this system? Suppose I am standing here, I want to measure distance from here to here. I will just switch on my laser L1, vary laser L2, see the angle. Either I can calculate using calculator how much angle is there, or I can use the same voltage reference for my ADC. We'll show that later and do. The second most beneficial thing is it's not about any single point. If I want to measure distance between in any plane between 2 points, suppose I want to measure distance between that point and that point. So first I will do the setup with this L1 and L2. This setup will give me V1. Now this L1 should be fixed anyhow, and from that I need to mark that second point and I will measure the distance. Since those 2 points are on the same plane, this will always form a right angle triangle and this distance will be As we can see that in civil engineering, marking and all is very important. And there is no possible way if you have to measure distance from that point and that point. You cannot put a tape and hang on there. So that's why this is the most important function for this setup.
Okay. Let's see about the errors happening in this. This setup is very useful for lower degrees only, because above crossing 70 degree means it shows very much variation. We can't able to get in this thing. That is the most important error. And see that unable fixing methods, nothing better. We can't able to fix that laser thing with this variable resistance. And limitation of movement laser point as per degree. As I told before, above 70 degree we can't able to take that much accuracy. And resistor inconsistency, that's it.
Apart from the practical error, we have some inbuilt error. The resistance won't be equal for every degree variation. And then ADC, ADC practical value and theoretical value will be different. So that error we have to put on. And then the stand function up to 70 degree, its change per degree is very low. But after that, it is lost. So we have to go for some other methods to find this stand function.
Okay, so the main problem is that only that for like 1045 I can measure 1045 is 1. That means my perpendicular distance will be equal to base distance. As I approach towards 90, that tan value with respect to degree changes very fast. Like 1070 will be some, 1071 will be higher value, and it goes on increasing. And towards 90 it approaches infinity. So the main problem is this. So this we can fix. If we have a longer base value, then our accuracy will be more. Because then we won't be requiring to approach that much higher or measuring longer distance. And also we have used approximation, so that will also, that limits its functionality. And then we have used the laser. So here the thickness of laser beam is approximately used to degree if we measure with respect to this arc. So that 2 degree won't count when it is around 60, 65, 70. But when it is reaching 71, 72, and we are not considered whether to take the regular or not, at that time it will count because that will be more difficult to multiply. Next.
So for now we have done this using the resistance method. Advanced we can go for gyrometer, which directly gives the angle.
Okay, actually before trying this system we had worked on a conduction method. Can I explain on board? Actually, instead of this arc, I was planning to have something circular motion and the conduction would be coming on this, and this wire resistance will be same. This side would be open, and suppose it is for this one section, so resistance for this one would be complete. Just 5 volt supply is using both sides directly. So we bought different wires of full from, but 650 and the wire was very big. It is very hard to make it exact. So we came up with this. Next time we will
So you said it's 58 degrees, right? How did you arrive at the number 58?
How do we arrive at 58? Sir, there the projector is...
Okay, so what angle did it come to? It came to 58 degrees.
That is 6 plus 58. Actually, my error...
6 plus?
Error plus...
6 plus?
My reading minus 6 is 50.
Okay, you're reading what is shown on the protractor, minus 6 is 58. Okay, so you got 64, it's 58. So according to your calculation, it comes to 2.87. Right, now can you help me with that voltage? 3.47 minus 2.90. That's 0.57 into 157 degrees. So it checks out that way also. What I want to know is how did you get it 100? I want to...
Sir, actually, this is change is 0.01 for 1 degree. So...
Okay, for 1 degree it's 0.01.
And this approximation also, sir, it doesn't go. It holds for 60 degrees. After that...
Okay, that you already told us. Okay.
I just had one question. What can be expected about the accuracy of the system?
Sir, actually, if we design, here we are using cellotape and all, still only 10% error we are getting in our hand. If instead of this we get something fixed, which is giving exact voltage for turn of voltage, the system will be perfect.
Do you have any ideas for correcting the system?
If I don't have this hill long, if I had something flat, I would have put 20 feet, it would have been perfect. But here, since I have put cellotape, this thing rotates this much without any change in resistance. So this is giving some error. So, but if we are trying to make it as product in factory, then there it is very pinpoint laser we can use.
For training purposes, it's fine. Why don't we have it as a next step? Why don't we find it a proper solution, have it as a flat one, and try to reduce the error percentage?
For reducing the error, you can increase the resistance, because then angle will be automatically reduced for longer distances.
That's an option.
That is a very good option, sir. I mean, I can just approve and I can get it 10 meter here. I just have to ensure that these two are on the same line.
Okay, do you have any mechanism or something, because it's just manual calculation right now. So, if we have...
Actually, using this voltage, we tried integrating it at mega. We got answer, but we didn't.
Yeah, I mean, we know about the electronic, everyone knows about electronic devices, it cannot be 100% perfect. What we are concerned is, it's a good one, it's a really good one, try to make it the best. The working is fine, everything is perfect.
We use gyrometer here, so in gyrometer there won't be any error. We just have to...
That's an option. But gyrometer might cost you more.
Yes.
The cost of the gyrometer would be there. So,
We use variables as potential, where we directly measure the potential and we do ADC. That is a bit better, but it is not a recurring process.
okay. With the safety and security regarding the lasers, be careful with using them. I hope you all know what lasers might do, so be careful with using them. If in case if it's possible, try to use maximum security lasers, and that is more important than the distance measurement. And spending in the laser is more important, is more valuable, is more worth than in the other equipments. Can I have approximately what it costed you for the whole thing? Can I have an estimated total cost as of now?
Actually, this is 2015, but here we get from 9500. This is getting 10. So this is the free cost. And that mega is we are using only for supply here computer.
Okay.
If we could have used it, then total cost would have been like, let's say 50, 100, and this something.
So, approximately 300 around. So, can you give me an application where it might be used?
Civil engineering, full on full. I am standing in this room is going to be built.
But
Someone is holding the
we all see civil engineers working over there.
leveling instruments.